Today we're going to learn about something called the multiplication principle, which helps us analyze numbers of possibilities. Let's suppose we have a company selling football jerseys in several sizes, and each size comes in two colors, red and white. We want to determine how many total types of jerseys the company makes. Here's one way to approach it. We can draw ourselves a tree with the sizes, so small, medium, large, XL, and XXL. Now each of these comes in two colors, red and white. Red and white. And so from here we'll be able to figure out how many total possibilities there are. So how many possibilities are there? We could have small red, small white, medium red, medium white. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 possibilities. This is fine when we only have 10, but what if they had 10 different sizes and 12 color schemes and 5 types of colors and some different choices for logos? We would not want to draw a tree for the whole thing. And that leads us to what we call the multiplication principle for counting. Suppose n is the number of choices, m1 is the number of ways to make the first choice, m2 is the number of ways to make the second choice, and so on. To determine the total number of choices, we multiply together all the ways to make each choice. So, in our football jersey example, we have 5 sizes, and we have 2 colors, and so therefore there are 5 times 2, or 10 possibilities. That way we don't have to draw the tree and write down every single possibility. Let's do another one. Let's examine the number of license plates that can be created if we use a letter followed by 2 digits and then 3 more letters. So we essentially have 6 slots, letter, a digit, digit, and then letter, and then another letter and another letter. How many ways are there to choose the first letter? Well, there are 26 letters in the alphabet, so there are 26 ways to choose it. How many digits do we have in our usual numbering system? 10. Digits 1 through 9 along with 0. So there's 10 ways to choose the first digit, and then 10 ways to choose the next digit. And then again, 26 ways to choose a letter, 26 and 26. This gives us a total number of possibilities, if you multiply these all together, of 45,697,600. That's the number of ways that this can be done. Now, if we add some conditions, let's assume adjacent letters and numbers must be different. So again, we're going to have slots here. Letter, 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 the second one's a digit. Letter, digit, digit, letter, letter, letter. Okay, we're going to figure out how many of each, and we're going to multiply them all together. So for the first letter, there's 26 possibilities. For the first digit, there are 10 again. Now, for the second digit, we only have 9 possibilities because we're not allowed to use whichever one was chosen to put in the previous slot. So we only have 9 possibilities. Now, it says that we move to the letters. Once again, adjacent letters must be different. So there's 26 possibilities for the first, Then for the second, there are only 25 because whatever was just chosen cannot be chosen again, because then we would have two adjacent that were the same. Now what about the last slot? Here, we cannot use the letter that was chosen in the second of the last slot, but we can go back and use whatever letter was chosen in the third of the last slot. So now we're back at 25. There's only one letter that cannot be used. Multiply all these numbers together and you should get 38,025,000 possibilities. Now let's suppose that letters and numbers cannot be repeated. So here our first slot, we have 26 possibilities because any letter can be used. 10 on the digits cannot be repeated. So the next one, there's again 9 possibilities. Now, when we move to our next slot, we cannot use the letter that was chosen previously. So there are only 25. Next slot, we cannot use either of the two letters that are chosen previously, so that means we only have 24. For the last slot, 3 letters are not allowed because they've already been used, and so that only leaves us with 23 possibilities. And so this will cut down on the total from our previous examples, and this is what we get. Products like this 26, 25, 24, 23 occur very frequently, and there's a special notation and even a special function on your calculator to deal with them. Let's start with the factorial. Okay, for a factorial, here n factorial just means we're going to take n, we're going to take the number that's 1 smaller than n, number that's 2 smaller, we're going to keep multiplying them together all on down to 1. You should have an equal sign here and an equal sign here. So 6 factorial will then be 6 times 5 times 4 times 3 times 2 times 1, which is 720. Okay, so 0 factorial, of course we can't have 0 in a string of numbers like this. It would make the whole string 0, and it probably wouldn't be very useful. And it's turned out to make formulas work, it has been best to define 0 factorial as 1. So 0 factorial does not follow the same pattern as the others, but it has been defined to be 1. Let's look at another example. If we have 8 factorial over 7 factorial, you can do this one without your calculator. Let's just think what's going to happen to these. 8 times 7 times 6, 5, 4, 3, 2, 1. That's 8 factorial. But now if you look at 7 factorial, 7, 6, 5, 4, 3, 2, 1. Remember that dot means multiplication. Notice that the 7 factorial, 7, 6, 5, 4, 3, 2, 1, appears as a factor of both the numerator and the denominator. Same over same is 1, remember, so these can be canceled out, as long as you remember that canceling means same over same is 1. You want to be careful using that word. Okay, you should also notice that we could have written this as 8 times 7 factorial divided by 7 factorial, and then once again we can use the principle of any number divided by itself is 1, and so we end up then with 8. Let's look at 97 factorial divided by 3 factorial, 94 factorial. If you try punching this directly into your calculator, at least on many models, you will find yourself with an error message. But yet we still need to be able to do things like this with our calculator. It can be done. So we're going to expand this 97 factorial and write it as 97, 96, 95, 94, 93, all on down to 1. Okay, and now what do we have here? We have 3 times 2 times 1. That's our 3 factorial. That one's not a problem. What about 94 factorial? What do we have? 94, 93, all on down 3 times 2 times 1. Now notice we have the same factor once again appearing in the numerator and the denominator, and you could cancel them off right now, or you could realize, just to show you how you could write this in a more compact way, we could write 97, 96, 95 times 94 factorial, and then in our denominator we're going to have 6 multiplied by 94 factorial. And so our 94 factorials cancel off and leave us with 97, 96, 95 all multiplied together and divided by 6, which is 147,440. Okay, I should point out that factorials become very large, as you may be able to see from here, but they grow probably even more rapidly than you might realize from this example. Let's look at 5 factorial, 10 factorial, and 15 factorial, and you should put these in on your calculator to make sure that you know how to find the factorial on your calculator. Oops, sorry. Let's go back. Here we go. So 5 factorial is 120. Just make sure you can duplicate these answers. 10 factorial, 3,628,800. So we're getting pretty big there, even though we don't think of 10 as being an especially large number. But now let's look at 15 factorial. If you put this in on your calculator, it may tell you something in this format: 1.307674368 times 10 to the 12th. And what that means, if you see that exponential notation like that, that means that your calculator has run out of space on the screen to put all the digits. This is what we call scientific notation. And so in order to convert that to numbers that instead of the scientific notation, in order to write it so that it is not in scientific notation, what we're going to do is we're going to write all these out, and we're going to put a bunch of zeros here, and then we're going to move our decimal place. It started out here right between the 1 and 3. We're going to move it by 12 slots. So 1, 2, 3, 1, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that's where our new decimal place will be. So that's a pretty big number just for 15 factorial. So if your calculator bombed out on 97 factorial and it would not compute it, you can probably understand why.